Glad to welcome Dr. Intille to WSU today. We have talked in the past quite a few times. I am very familiar with his work. Dr. Intille is a professor of computer science and health sciences at Northeastern. He has worked for quite a while on computer science-based novel approaches to healthcare technology that uses ubiquitous computing, user interface design, pattern recognition, behavior science, and preventive medicine. He's been working for a while in behavior modeling and activity recognition, digital health, and recently his work came to my attention because he's done a lot of really interesting things on in-the-moment assessment. And so many of our projects use this. I think we can really benefit from learning about what he has been doing. So I will go ahead and turn it over to him to start. And thank you, Stephen. Take it away. You are muted. Yeah.
There we go. And I got to get rid of all these, okay, Zoom windows and stuff. All right, there we go. Well, thank you for inviting me. It's my pleasure to be here. What I'm going to try to do is give you a sense of how I got to where I am in terms of what we're doing with EMA today, which is mostly what I'll call microinteraction EMA. So I'll take you on a little journey from sort of where I started to where we're at, and then give you a sense of some of the projects that we have going on today. Oh, that is my goal. I can't really see the chat or anything, so if somebody has a chat question, that like clarification question, if you put it in there and somebody else interrupts, that would be great, and ask me. But I've been told to go about 45 minutes and then try to leave some time for questions. So that's what I'm going to try to do. I packed a lot of stuff in here to give you a flavor of what we do, but the basic takeaway is that self-report's necessary for future research and intervention development. EMA is a useful measurement technique in research and specifically on activity and behavior, but it's not without its weaknesses. And I think there are opportunities to develop temporally dense self-report methods, which I call microinteraction EMA, that may be more feasible than they may initially seem. So that's what I want to convince you of today. Sort of backing up, I think new measurement tools are really what accelerate scientific discovery. So if you think about at a massive scale, we started off with simple telescopes and then we got bigger and fancier. And every time that we did, we have sort of amazing discoveries. This is an image from the Hubble. Right now we have an even more advanced telescope out there. And at the micro scale, it's the same thing. Every time we go from simple microscopes to fancier microscopes to electron microscopes, there are scientific discoveries that come out of that. And then now we have essentially genetic microscopes, right, that can look into DNA data. So if you then say at the behavioral scale, where are we at? We're actually, I think, at a pretty primitive place still, despite all of what many of us are trying to do. At a typical NIH grant review meeting on research related to health behavior, I think there's this elephant in the room often, which is where does the behavioral measurement come from? And it's oftentimes it's from retrospective surveys that we know are not reliable. If you've ever gone and taken like a dietary survey, you know that they're almost comical when you try to fill them out. They ask sort of ridiculous questions. And if we improve our measurement, we're going to do better science. And we know in health that a huge amount of our health is really reliant on these behaviors, not just our genetics. And so we have to measure the environmental impact, environmental factors, even just to understand the genetics. And then all the stuff that we always hear about in terms of health, like, that influences how long we live and how well we feel, taking drugs properly, stress, behavior and lifestyle, all of these things we actually measure pretty poorly on the whole. Diet, physical activity, standard behavior, risky behavior, medication adherence, socialization, assessment of pain, stress and stressors, affective state, and sleep duration, patterns of sleep. All of these things we know are super important, but if you actually then look in the literature and say, how are these actually measured in most of our studies, I think it's a little scary in some regards how poor some of the measurement tools are. So if we think about the behavioral scale, we can use technologies, digital breadcrumbs as some have described them, to detect patterns of behavior by computer. That's what we want to do. And we might be able to measure across these health silos. So rather than just having sleep people measure sleep and having physical activity people measure physical activity, we really want a comprehensive view of somebody's behavior throughout the day. We want to understand unexpected relationships between their behavior and their health outcomes. And I'm interested in developing then computational models of behavior change, with the goal of reducing the measurement noise to advance science. And there's definitely a need for this, because if you go and you look at the NHANES study, which is really one of our best views into behavior in the United States as it relates to health, and you look at self-report data for whether or not US adults meet the physical activity guidelines, you'll see that about 45% of the people might meet that. But if you then look at measurement from an accelerometer that they wore, it's less than 5% meet the guidelines. And researchers who work in the physical activity space think that the truth is somewhere in the middle, and we have to figure out how to measure that truth. So the bottom line for me is that I want to have better measurement of behavior so that we can ask better questions. Things like, do short bouts of activity, are they protective against disease as continuous long bouts, or does breaking extended sitting contribute to health in some way? And until our measurement is better, we really can't even think about these questions. So I'm trying to think long-term in terms of measurement. And then there's two reasons you want to measure. One is scientific inquiry. So that's better tools for scientists. And most of what I've done is really still in that space. But we also want to build effective interventions where we can measure these changes in behavior and state and then intervene with just-in-time interventions. And I think the thing to keep in mind is that in the second case, that's going to require longer term, less invasive measurement than scientific inquiry might. But still, at times, there's going to have to be reasonably invasive measurement and self-report. To get to this idea of digital models of behavior, we want to incorporate real-time behavior, state, and context, and build these probabilistic models of current behavior, next behavior, and then ultimately I'm interested in habits and habit formation. Is there a question in the chat? Because I cannot, okay, that's just a chat question. All right. So, Zoom. There we go. So this is a graph that I made a long time ago. I had a wrist and ankle accelerometer, and I hand labeled the things that I'm doing. And I've been wanting to get to this for a very long time, and we're still not there. So we have devices like Fitbits that can measure some of what we do, maybe not quite as accurately as the companies claim that they do, but they're not measuring everyday habits. And so this is sort of one day for me, and then I'll scroll through, and you can see in the top left here, it says hitting snooze, and there's two little bumps, and those are hitting snooze on an alarm clock, old-fashioned alarm clock. And then I go out and I walk my dog, and then I shower and get ready for work, and then when I'm on campus, I'm in meetings sometimes, and then sometimes I'm just working at night, and then there's posture shifts at night. Sometimes sensors die, right? So lots of things happening. Then if you see on the top right, there's three bumps again, a couple bumps again, that's hitting snooze, right? So just from the accelerometer data that I plot here, you would never know that. But for me, that's a pattern that starts to become apparent over time. Now, the question is, how do we get the data that we need to figure out that just for me, that is the hitting snooze, and that for me, in a meeting looks one way and lecturing looks another way. So for a long time, I've been trying to get to this point, and we've done a bunch of work on activity recognition as Diane and others have done. And it's, it works on lab data. It kind of works on real world data, but we still can't achieve this. So we're trying to get more sensor data to make this more viable. And I've done a lot of lab-based experiments, putting sensors all over people, all different types of sensors, and collecting data on them, labeling their activity. And this is some old work. If you simplify it down and say, all we care about is postures, then the devices can do really well. If you say in the top row there, I have 51 different activities, then it does okay if it's subject dependent. It does less well if it's subject independent. And so the subject dependent is where I have subject specific training data. So I'm interested in how do we get that training data in real life from real people. Here's another study. This was just wrist versus ankle ambulation detection on 33 people. So and we just had not a lot of categories: ambulation, cycling, other activities, and sedentary. And we can do, again, okay, but we are always doing better if we can get training data from individuals. So I've been doing this stuff for a long time and trying to get to the point where we can do it reliably in real time, even on things like smoking detection. This is an old study that we did, and others have followed up on this. But basically, if you have very simple movements, you get simple patterns in the accelerometer data, and you can say, okay, this is a puff. But as soon as you start moving to real world data where you have eating and smoking and people moving around, then it doesn't look like this very often, where it's just sort of this simple puffing kind of pattern. The bottom line for me is that even for activity recognition, I think we need self-report. And then there are other areas like pain, measurement of pain and measurement of mood and perceived exertion and relationships, where we might get some passive sensing data. And obviously, if we can get passive sensing data, that's what we want to do. But we're going to need some self-report. And I think we're going to need self-report even to train the activity recognition algorithms. So that kind of launched me into, trying to use EMA to some extent to gather data from people in the moment. And so this technique's been around a long time. It became more practical when everybody on the planet got mobile phones, essentially. And now we use this in a variety of studies. And usually it looks like this, standard EMA type of multiple choice question. And the value of EMA is that you're getting prompted on the phone, and it's going to reduce these recall biases that are problematic with the surveys. And it might be used to explain missing sensor data that you can't get passively, for example, or you can't interpret passively. So it has potentially real world ecological validity, which is the appeal. But making this easy really matters. And these simple little things, you may have seen them some places. It turns out they're very, very effective at getting people to give feedback. And in some ways, they're very different than a typical EMA survey, which if you run them on yourself in a typical health study, you know that they are not that easy to do. They tend to get pretty burdensome and annoying after a certain amount of time. And there's this huge amount of tension between researchers wanting to ask a lot of questions about everything and participants needing to have a very simple thing more akin to this, where they can report what's going on with them. So that is the challenge that, one of the challenges that my group is sort of looking at these days. We want to reduce the recall bias. So you could have a pain questionnaire like that one in the bottom left with recall bias, but we also we want to be able to measure things as passively as possible with the wearable sensors. And we want to kind of get the best of both worlds. We want momentary assessment that isn't too burdensome. So again, here are some standard EMA questionnaires from various studies that I've run. And they're just asking, how mad or angry are you? What are you doing? Since the last survey went off, what's been going on, right? Are you stressed out? And the research on EMA there's not as much as you would think, given that the methodology is getting more and more popular. But typically in an EMA study, as this one shows, they typically last about 7 days. They may have about 6 assessments a day. And usually you're seeing compliance rates around 79%, 60 to 80%, I would say, on the whole. And that's when you're providing financial incentives. So if you think about long-term and we want to have just-in-time adaptive interventions, we're not going to always be able to provide financial incentives, or even for research studies, it's hard to provide incentives for long periods of time. The strengths are reducing the recall biases, ecological validity, simplifying data collection, inexpensive to deploy usually, and you can use the device capabilities like cameras, sensors in interesting ways. The weaknesses are compliance and burden, which you try to offset with compensation, and then it can be difficult to verify the response validity. The researcher doesn't want to relinquish control over the prompting. The user interface limitations on input can be tricky, and possible reactivity. So if we look in the literature, again, on the validity, this paper, the conclusion is results showed that the correspondence rates varied considerably across individuals, behavior and studies, and this is where they had a gold standard measure of validity, and agreement rates ranged from 1% to 100%, and no unifying variables could be identified across the studies that found high correspondence. The findings suggest that EMA can be an accurate measurement tool, but further research should be conducted to identify procedures and variables that promote accurate responding. And reactivity, there's relatively little research looking at that. So generally, there are some studies in the space of looking at people who are potentially suicidal, which you would say is sort of the worst case scenario. You don't want to trigger somebody to feel more suicidal by asking them questions about it. And the evidence from the small number of studies that are out there is that it's not, doesn't appear to be that reactive. Yet, this was a relatively recent study from Penn State where they had a smartwatch and they were asking questions, and what they find in this study, oops, which I'm missing a slide for. So the result of this study is that, and I'll provide the slides with if you want to, and there's a reference to this paper. So in this paper, they find that there is some reactivity, and that if you ask people to monitor their activity up to 3 times a day, it seemed to have some impact on what they measured from the Fitbit. And then beyond that, it didn't seem to have much more impact. So there is a little bit of study on reactivity, but not that much. The bottom line, though, is this huge Achilles heel is the burden of this technique. And so one way you could address that is you could try to use context to target the questions. And I've done that a little bit. Oh, it's out of order, I guess. This is the Penn State paper on dose response. Sorry about that. So where they're saying that after three prompts seemed to make a difference, and then after that it didn't. But back to context sensitive, we've done some pilot studies where we had like an asthma inhaler, and then we trigger the question only when the kids use the inhaler. And that makes a lot of sense because you don't need to ask inhaler questions typically unless they're using the inhaler, at least in this particular study. And we've done things where we prompted based on phone motion or no motion. And so then you're targeting a question based on something that you measure. And then we've also done work where we showed people their data and then basically clustered it up automatically and then let them easily click on a button and indicate what they were doing for a period of time. So we're trying to make the self-report easier by showing them their own data. So this is sort of a combination of passive data collection and retrospective filling out of what they're doing, but in the context of everything else that they were doing. So sort of a reminder. So we've tried some of this stuff. Oh, and then we have an ongoing study. Still, we have a follow-up to this one that was published where we measure what's going on in sleep during sleep when they can't answer questions, and then we ask them questions in the morning about sleep disturbances. So that's a case where it makes sense to use passive sensing to trigger active sensing. But if you're doing a study, oftentimes the complexity of having the algorithm doing the triggering can mess up your statistical analysis when you ideally want random sampling. And so you're still left with this idea that a good chunk of the time, the limitation of the EMA is that you really do want, to some extent, random questions, not always triggered based on behavior. And you want a decent number of questions in some applications. So the interruption burden is coming from these long question sets, frequent questioning, pulling out your device and looking at it, and the disruptiveness of the prompt. And it raises the question, we have this high perceived burden and lower study compliance. Is there anything we can do about it? So this is what we've been sort of trying to explore a little bit. Can we achieve high temporal density in EMA? And our idea is pretty simple. It's that you want to use what we call microinteractions. So these are at a glance interactions, and it could be on a smartwatch or it could be on other devices. But the idea is you have a cognitively simple question and you pop it up, and you might pop it up many times an hour, and then people answer the question. So initially when people hear about this and they say, well, we're going to prompt people for 4 times an hour for a year, they say, okay, that's crazy. That's never going to work. That's going to drive people totally bananas. But this is what we're trying to do because we want to be able to have temporally dense questioning. The way to think about a microinteraction is it's something that you hardly have to think about if you think about turning on a light or flipping a switch. Something that you could do in the middle of a conversation. It might take you about 2 seconds to do. And what we're exploring is, can we use EMA with only micro interactions, and is that useful in various domains? And it might look like this on a watch. So are you feeling excited? Yes, sort of, no. So we've simplified the question. everything about it is simplified, right? And one of the key things is that it's guaranteed to be one question. So when the prompt goes off, one hypothesis is we have is that people, when the prompt goes off, people will think about the worst case scenario, and that's what's going to cause them to decide whether or not they answer the question or not. If the worst case scenario is never worse than a microinteraction, then it's as easy to answer it as it is to ignore it. And so that's in part where we think that the value of this comes. So with a typical EMA interaction, you would have a prompt, access your phone, unlock the phone, and then a whole series of questions. In micro EMA, you have a prompt, you access your watch, which is right there, you tap, answer the question, and you're done. So it's sort of a 2-second interaction. And from wake time to sleep time, you might have in typical EMA a bunch of surveys like this. Sometimes they have skip questions to try to make them easier. But I would argue that the worst case scenario, the one on the right, is the one that people remember. And so the next time it gets prompted, even if it has a bunch of skip scenarios, I don't think it really matters. So I've been in many, many conversations with my colleagues, behavioral science researchers, and then we're trying to say, well, let's make it less burdensome by just having skip questions. But some of the time, we're going to ask all the questions we want to ask. And I think the problem with that is that people remember the worst case, and that's probably driving their behavior. So in micro EMA, this is the worst case. The worst case is always the same, and it's this micro interaction that hopefully takes not much more than 2 seconds. So bottom line is in mobile EMA on a mobile phone, we interrupt less and ask more. And on the watch, we interrupt more and ask less. And the question is, okay, what's the impact of that? Because if you believe that the primary burden is the interruption, not maybe the time that it's taking to answer the interruption, then the micro EMA could be very problematic. So we run a couple pilots to try to tease this apart and figure this out. So in the first pilot we had people using micro EMA, and we asked them, we had 8 times more interruptions. So the same number of questions on EMA and micro EMA, but 8 times more interruptions with micro EMA because we only had 1 question per interruption. So even at those high response rates, the micro EMA on a watch had higher response rates and study compliance than mobile EMA. And despite interruption rates as high as 8 per hour, the watch micro EMA was perceived as more tolerable than the mobile EMA. So some people find this counterintuitive because they say the interruption is what would be the problem. Well, we got asked when we put that paper out, is the effect due to the micro interactions or to the smartwatch alone, right? Because maybe it's just that you moved the survey to the smartwatch. And so we did another study where we looked at that. So we had EMA on the phone, EMA on the watch, and then we had watch micro EMA. So EMA on the watch was a bunch of questions on the watch, and EMA on the phone was the normal questions on the phone. And this is, you balance out, you have all the same number of questions. And in this case, for compliance, which is how often they respond overall based on how many messages you wanted to deliver, and also completion, which is how did they respond based on messages that were actually delivered. So if you turn off your device, you could have something where you have a very high completion but a very low compliance, basically, because you only got delivered 2 questions and your device was off most of the time. Compliance is considering everything. So, and oftentimes in EMA studies, people call what I would call completion, they call it compliance. So they have very high compliance, but sometimes the devices were off for very long periods of time. So we measure them, we keep them separate. But in any case, you can see here from the graph that the watch micro EMA is outperforming the watch EMA and the phone EMA. And here's the summary of that. So watch micro EMA, despite a lot of interruptions, does pretty well in terms of compliance, completion, and also if there's a reprompting, people tend to answer it on the first prompt, not the reprompt. Okay, well, so if the novelty of the smartwatch and its easy access, if that's not the thing that's really making this work, it appears to be the actual micro interactions that's making this work. So then we did another small study looking at the validity of it, because it could be that people are just tapping the watch and not giving valid answers. So in this case, what we did is we had people answer micro EMA questions that related to physical activity, and then they had an accelerometer on their body In this case, I think it was on their ankle. And then we looked to make sure that we had high validity between the actual answers and the actual measurements. That yielded accurate self-report at that high frequency. And the technique has been used by others to measure stress and hyperarousal and perceived comfort at this point in real world settings. And then what we've done is we were running another study, which is an intensive longitudinal study for a variety of purposes. And this study had very intensive sensing. So we recruited, we had a target of about 250 users for an entire year of data collection. So they were, here you can see in the study for the year. And then if I zoom in on 1 month, we had them doing baseline surveys and things like that. But in a given month, every day they had end of the day EMA diaries. And then they also had 4-day burst periods in each month where they did hourly EMA surveys. And then the entire time they were awake, in the days when they weren't doing the EMA surveys, then they had micro EMA for up to 4 times per hour. So you can see that it resulted in an awful lot of prompting for the individuals who are in this study, both regular EMA and micro EMA, a lot of passive sensing. And in this case, people, and these were, I should say, emerging adults or 18 to 29-year-olds. And this is part of the data. So for 6 months in this case, for people in the study for 6 or more months, you can see that they got an enormous number of micro EMA prompts, but the compliance and the completion actually remain pretty high. And they were not compensated for the watch surveys. They were compensated for the EMA surveys, but they were not compensated for the watch surveys. So effectively, they weren't getting anything for doing it. It was just sort of there as part of the study. The thing that actually determined how much compensation they got was were the EMA studies. So this is showing that people could keep this up for quite a bit of time. Again, the compliance and the completion of the micro EMA is on par or better than the compliance and the completion of the EMA. And it was happening far more often. We also then took that same data because we had a lot of passive sensing data from the watch and the smartphone. And then we looked at, is there a relationship between certain contextual variables and whether or not people are responding? So we had a lot of different types of variables that we could look at here. And the ones that are highlighted in this paper, which just got a best paper award from IMWIT just last week. So we're happy about that. There was some relationship found with some of these variables. So I'll show you here. One of them, like micro EMA completion, people were less likely to answer micro EMA prompts closer to their sleep and wake times of day. They were least likely to answer micro EMA prompts in the first quartile of their day, so sort of in the morning. Whereas with EMA, there was no significant difference between any quartiles of the waking day. And here's sort of, it's a little confusing because over the course of the study, the number of, this is the number of days they were doing micro EMA and the number of days they were doing EMA, and the number of people in the study goes down over time because of the, not everybody at this point finished the entire study. So the bottom line on this is the completion and the compliance for the EMA. Oops, I thought I had a summary of it. They remain reasonably steady over the course of the entire study, which again, looks like it's confusing because it's 280 and 120, but that's because they did EMA 8 days a month and they did micro EMA the remainder days of the month. But you can see that they both drop a little bit, which is what you'd expect, but they're not dropping, it's plummeting as well. So the summary of that study is where in aggregate, people had an enormous number of micro EMA prompts. There is some impact from the context. The more micro EMA non-response near wake times, more micro EMA non-response on weekends versus weekdays. The micro EMA non-response was higher at lower wrist motions, including non-wear and device charging times. and micro-EMA non-response was lower at home versus other locations. So definitely some impact, which you have to be aware of. But at the same time, they were able to sustain this for quite a long time. So my hope is that as our passive algorithms get better, that we can more strategically ask questions. But I think the exciting part about this is you have the opportunity to be asking lots of questions and potentially not be afraid about that if you can keep them micro interactions, which is a trick. So a limitation here is that this was all done during the pandemic, so that might have influenced had lower mobility patterns. We were only looking at the motion summary from the wrist, or we did. It's the summary that we used. It's just from the wrist. It's not a specific activity type, so it's like an aggregate motion amount. So we could try to break that down into type of behavior a little bit more. That might, in certain types of behaviors, might have different effects. We measured device use was measured from the smartphone, not the watch, and a couple other limitations. We didn't use other types of sensors like heart rate monitors, things we could do. So in the future, we want to do sensing plus micro-EMA in real time, and we would have already done this, except for real-time stuff is so difficult to do at any scale on these, especially on these watch devices right now. It's very tricky, but we'd like to have motion plus heart rate plus location, and then trigger a micro-EMA prompt, and then basically have that feed back in to improve the activity recognition. And that's where we're headed. We'd also like to do the same thing with galvanic skin response and heart rate variability and feed that back in to improve the recognition. And I would say that the only thing is holding us back from doing this at this point is computation on the devices and battery life primarily, and the flakiness of the mobile devices. But I want to give you a sense of one project we have going on right now to collect data to try to figure this out, but it also motivates why we're interested in micro-EMA as well. So I have a project we call it PAWS, is the acronym, because we're Northeastern Huskies. So the PAWS, our Husky is our mascot. But the whole point of this project is to collect data for activity recognition researchers who want to do a better job of recognizing, building algorithms that detect specifically physical activity, sedentary behavior, and sleep. So I'm going to play a short bit of a clip. Can you hear the audio? You hear the audio? Oh, no? Okay. So what I'll do is I will mute my audio. Okay, well, if you can't hear it, it doesn't matter. So this is a video that we have for participants in the study when we're recruiting them. And what it's showing is the type of data that we collect from them. And let me turn this down. And you'll see the types of sensors we're using. So we have them do 2 nights of polysomnography for sleep. That's what the data you're seeing here is. We have them wear sensors for an entire week on pretty much all their limbs. And then we have them come into the laboratory for about 4 hours where they wear accelerometer actigraphs. And then they have many more sensors on their body for that 4-hour time period. So when they're in the lab, we put a lot of sensors on them. But even when they're at home, this person, who's my mother acting in the video, she's wearing the camera, which is a front-facing camera. And they go off for a week wearing that camera and recording video basically the entire time. So then the video is used so that we can then annotate what they're doing as best as possible. So there's the video camera, which unfortunately is much larger than we want it to be because of battery life issues and things like that. But they wear this camera for a week, recording most of what they're doing. And then they come into the lab for an activity protocol. I'll sort of skip ahead on that. They come to our exercise phys lab, and then we have them do a variety of things in the lab, little exercises, walking on the treadmill, riding an exercise bike, sort of simulated household activities. And then they also go outside, they ride a bike, they walk around campus. They're doing lots of different things, and we're labeling everything they do during this 4-hour period. They also, for a short period of time, they wear energy expenditure measurement device. And then they also, 2 nights during this week, they come into the lab and they get wired up with polysomnography, because this is what the sleep researchers made us do, because this is the only thing they consider a gold standard. As crazy as it is, because we wire them up with all these sensors, they go home and then they sleep, and they're supposed to sleep naturally with an enormous number of sensors on them. But this is the sort of gold standard that the sleep research community is interested in. And so as part of this data set, there's also 2 nights of sleep data where they're doing full out polysomnography. And then our research assistants talk with them every day about sort of doing an activity recall and filling in their day. And then we have the video that we collect, which we then annotate. So why is this relevant for micro EMA? Well, I'll show you another. This is, oh no, come back. This is an example of the type of video that we get. So here you can see, this is my collaborator wearing the video, not an actual participant. So you can sort of see what's going on. Here's a case, you can see he was driving, he stopped, and then our annotators are watching this video essentially and then annotating what's going on. So in this case, they would have annotated that he was driving, and now they would annotate that he's standing, and they're trying to sort of understand what's going on, and they're annotating this. Meanwhile, he's wearing sensors on all his limbs, and we're collecting as much data as we can. So now he kind of stops, and what he's doing is checking his phone. And so he's in the middle, like you wouldn't expect him to necessarily be standing here by the car checking his phone, but that's basically what he's doing. So this would all be labeled as kind of standing around. And then eventually he, if I fast forward, he's standing there for quite a while. It shows you how we get distracted by our phones, actually. Keep going. Okay, so now here he grabs some bags from his car, and then they would annotate that now he's carrying bags, which changes the way that he's walking. It changes the movement of his arms, right? And then he's now going to go up a couple short little bit of steps, and then he's going to go inside. And this is the type of video that they're basically then annotating. And if they can't figure out what's going on, or if there is no video for a period of time, then in the recall, they try to fill in the gaps as much as possible. So this is our project that we have, and so far we have 185 participants. We're headed towards having 300, and we have a decent mix of men and women and different ages of people right now. But this relates to micro EMA in a painful way, because we have a fairly complicated behavioral ontology, and this is for the free living part. There's a sort of basically the same for the lab part, but we label postures, high-level behaviors, physical activity type, which is really our primary thing, contextual parameters, and then the experimental situation, whether it's the lab or the free living. We're trying to label all of this. Any of you who have done anything where you're labeling data, probably are thinking this is a total nightmare, and that is pretty much what it is. So we bit off more than we could chew here. One of our problems is recruiting. And the biggest problem there is the camera. It's not something that can't be overcome, obviously. We managed to find people to do the study. But if we could get rid of the camera, we could find a lot more people to do the study. And in the future, if you believe that the activity recognition algorithms that we want to create are going to require some amount of personalized training data, then we have to figure out a way to get what we need without this, probably without this camera. And so that's sort of one issue, short term and long term. And the other is that annotating all of this video is just a nightmare for an academic group. And so that has led us back to micro EMA. And in this case, we're now doing preliminary work with audio micro EMA. And so here what we're doing is we're trying to get at some of the limitations of the watch EMA and see if we can help ourselves on this pause study that we got ourselves into. So we have limited screen space on a watch. So that's good for confirming predictions, but bad for open-ended responses. And if you have like 20 odd something activities, it's hard to do, unless it's predicting it in real time, it's hard to do a yes, no, maybe question, right? So eventually we want to predict it in real time, but right now we can't do that. So that's an issue. And then looking at the watch screen, even if you're like, when the person got from their car and they're carrying these bags, if the micro interaction goes off right then, it's hard. You have to lift up the bag, and you've got like a sleeve, and you have to answer. And what you really want to do is you just want to say, I'm carrying groceries into the house. Like that's what you want to do. You want to get the prompt and just say what you're doing and be done with it. And so that is what we're exploring now. Can we make that work? So we're taking commercial earbud devices, and we particularly like the Shocks, or we started with them because they are over the ear, so it's safe to wear them all about. They're not blocking your hearing, so you can hear other people and you can hear the thing whispering in your ear. And basically what it does is it prompts and it whispers in your ear, and we train people and say, what we want you to report is your posture and what you're doing, your posture and your ambulation. So right now I'm sitting and I'm giving a talk on the computer, or I'm sitting and I'm in the meeting. So we ask them to report that. And then what we're studying is if we get the audio from the headset or we get the audio from the watch, how is that going to work? And there's sort of two ways you can get audio from the watch. You could talk to the watch like this, which is not what we want them to do. Or you can just do what you're doing and say what you're saying, and the watch picks up the audio as best as it can. So here, the watch micro EMA is prompting vibration. You access the watch, you answer the question, and you complete the survey. We're trying to simplify it even further. So now you have a vibration or a beep, you speak, and then you're done, right? That's the goal. And the question is, can you do this 2 times an hour for 14 days? And so far, we've had a limited number of people do this. What I have here is about 9. We've done more people since then. We've had 9 emerging adults, and they're interrupted between every 2 and 5 minutes. And we have verified that they are able to do this without going insanely crazy for very little compensation. And what we're studying is what is the best modality to really do this in. So we're comparing the watch versus the earbuds, and things like the comfort of the earbuds become important and all that. And then we listen to the audio and run it through speech recognizer to see how often could it detect it automatically, which would make some real-time work possible, and how often can humans even understand what's going on. So 97% of the responses were intelligible, but the speech recognition doesn't do nearly as well. And this is sort of across the different devices. So the completion rate, this is over 7 days here. For watch micro EMA, what I was talking about earlier, we have a completion rate of 73%. This is again at a very high, relatively high rate. The watch audio micro EMA at an even higher rate, and a headset audio micro EMA also at a high rate. And you can see that the completion rate is pretty good despite a very large number of prompts answered during the day. And then what we're studying is like how much of that audio is intelligible, how much of it is useful. And this is very early work, but we're trying to see, can we get around some of the limitations? And what we found so far is that one of the limitations is anxiety when reporting in social settings. So it's interesting that like people don't want to talk out loud when they're around another person. They would then prefer to have the watch. But when they're doing the watch and they're doing the audio, it's very difficult to get them to just speak without going like this. And so what happens is they assume that they need to go like this even when we tell them that they don't. But if they do this, then they're making it more burdensome, which is what we're trying to avoid. So if you're carrying 2 bags, we want you to say, I'm walking carrying bags, and we don't want you to move your arms. We just want you to speak normally. So we're in the very early stages of this, but we're trying to explore how does this affect how people answer the question, and sort of what are the cognitive loads and things like that of this, and trying to figure out ultimately, can we use this for activity recognition training data at a very high sampling rate, with the idea being that maybe you only have to do this for 2 weeks, and then you've trained up your system, and then it goes more into micro EMA where it's confirming what it thinks you're doing. And that's sort of the direction that we're headed in. The last thing here, I think in 3 minutes, I'll give you a flavor. We're also trying to do this in populations with very significant challenges. And so one that we've tried recently in a very small, again, feasibility pilot is persons with aphasia. So aphasia affects people's ability to produce and comprehend complex language, and anomia is where somebody knows what they want to say but is unable to retrieve the word. So that's what persons with aphasia have. And so we have a collaborator who works with this population. EMA has not been used very much with this population, and it's challenging to use generally. Most of the time when you're assessing individuals for aphasia, it's done in a clinical setting, it's done only once, it fails to capture like all the complexity of everyday life, and they basically need better tools. And so in this little feasibility pilot, which just is getting published at Assets, the upcoming Assets conference. We had a very small number of people because it's a very challenging population to work with, but we did audio-based EMA. I'm not sure I'd call it micro EMA in this case because it takes them a little while to answer. These are post-stroke adults, 52 to 79 years old. And I'm not going to go into the detail of the protocol here, but we sort of tried one case where is single image EMA, they did one image at a time, and another case where they were clustered up together 9 images at a time and kind of comparing them. And what they would see on the smartwatch is a picture, like one of these pictures here that are standardized pictures used in aphasia research. And they would have to name those pictures. And so here's one individual, he gave us his permission to use his actual photo here because he's very proud to have participated in this. And he would answers the question on the watch. They come in for 1 day of sort of testing, and then in day 2, they would be trained on how to use the watch. And then during the study, they would see pictures like this on the watch, and they have to name the picture. So it says ready to beeps or vibrates, says ready to name a picture. They say yes, and then the picture comes up and they have to name the picture, which for them is a difficult task. And then throughout every week, we assessed how they were thinking about this simple scales. And at the end of the day, the average completion and compliance for this group, again, only 6 people, but it's in the 80% range, which is pretty good for our aphasia collaborator. Thinks is pretty good. So we think that this has some amount of promise despite all the complexities of working with this population. And then we're also looking at how many of the responses are intelligible or where they sort of just sort of no naming attempt, or whether it's unintelligible because they are listening to the audio. So this is a human listening to the audio, trying to figure out how many of these responses are actually usable. And then how much background noise and that sort of stuff is there. So I would say the bottom line, I'll wrap up here, additional considerations for all these studies is the smartwatch work is actually pretty challenging, I would say. I had a lot more hair before I started this smartwatch stuff, that's for sure. The operating systems just changing all the time. The app approval process has gotten ridiculous. And you have to have remote systems to monitor things in real time. Otherwise, you won't get good data. But I do think that there's a lot of promise here still, and that we're going to need high temporal density self-report to do the types of things that many of us want to do eventually with just-in-time interventions and reliable activity recognition. And so I think it's worth it to explore this type of thing and see how far we can push it. And ultimately to see if we can combine this with computational models of behavioral measurement and real-time report so that you're not always asking the same questions all the time, but you can still ask questions in a temporally dense way for short periods of time if you need to sort of bump up those models, and then you go back to not asking as often. So I think that's kind of the long-term vision. So thanks for your attention. I'm happy to answer questions. And of course, want to acknowledge all my students and collaborators and grants.
Thank you so much. That was fantastic. So if you can see the participants, Stephen, then you'll see people raising their hand. Okay. Otherwise, I can now see you, and I can.
Okay, so I see. Let's see. I don't see raising of hands yet. You must have some questions. Normally, behavioral science people push back. They don't like this idea of these simple questions kind of drive them crazy. They're like, well, wait, how do I answer my validated question? You know?
Absolutely. Oh, Shelley has her hand raised. Shelley, go for it.
Can you hear?
You're muted.
Can you hear me?
Yes, now again.
Okay. All right. Well, thank you for this great presentation. So my background is nursing. I have 30 plus years in nursing, about 22 of those on the front line. And so I work with Diane on this whole idea of how do we understand people's behaviors in the aspect of understanding clinical health. And so I'm wondering a couple of things. One, I saw that you had different age groups, and I saw that on one of your slides, you're looking at age 55 plus. And I wondered how you came up with that number of 55. And then I'm wondering if most of the testing that you've done on younger adults, if you think that that would translate as far as accurate behavior recognition in older adults. So we don't have to train older adults using like the smartwatches, which is really hard for some of our older adults.
Well, okay, so you have multiple aspects of your question. Some of my age ranges is opportunistic in that, you know, my collaborators are interested in certain ages, and that's how we end up doing those sorts of studies. Some of it is because, like, the year-long study, that was actually the NIH put out a call and was mostly interested in younger adults, but also it was because they were all technology focused, and the idea was it's going to be hard enough actually to do this on anybody, and that's a population that's using the technology now. So let's see what we can do. I think that for older adults, if the technology works the way it's supposed to, I don't really have any problem with older adults can use it just as well as younger adults. Most of the technology doesn't work the way it's supposed to, so it tends to be more burdensome then. I mean, we have a lot of problem, like in that aphasia study for sure, you know, as all of you know who deal with deploying technology in the home, you ask somebody, we're not getting data, we're trying to figure out why, what is going on, and then they tell us that they don't have internet anymore, and we're trying to figure out why is that happening. And then ultimately, my collaborators realized they only understand Wi-Fi. They don't know what internet is. So they were all having this conversation, not understanding each other, and you know, those sorts of things go on a day-to-day basis. But a lot of that stuff is happening because the technology is kind of too flaky to begin with. I think most older adults could perfectly handle micro EMA on a smartwatch. What is hard to deal with now is the smartwatches are too unreliable to easily deploy. Like, all of the problems that we have tend to be because of Android and stuff like that, and phones. It's like, has nothing to do with the actual micro EMA. It has to do with all the other stuff, the technology kind of that's around there to make it work. So I don't know that I answered your question all that well. I mean, eventually, you know, as all of us are aging, right? And so there will be more and more understanding of tech because people have basically grown up more with it. So that will filter up, but I think that methodologies like micro EMA, older adults can handle it perfectly fine. Where it gets hard from a research perspective is all the logistics and stuff. It definitely becomes harder because if there is anything, like if Android does something weird, it's harder to debug it remotely with them. So it ends up taking a lot more time. Like of staff, it just takes a lot more time. And I think that's, you know, when you have a limited budget and a limited number of people, those sorts of things become very salient, for better or for worse.
Thank you.
Yes, they do. Maureen, you have your hand up. Oh, you're muted.
Yeah, thanks. That was a really interesting talk. I could relate to a number of those things that you mentioned in terms of some of the challenges. I think the micro EMA is very interesting for specific types of questions. I think with activity recognition, it really fits well there. I did in terms of like actually using the audio, like having them speak. I think that's really interesting. I do think that cognitive load question is going to be a very important one, because I'm thinking like when you start asking people to kind of formulate what they're saying, like even that the other study you did was really fascinating, and that seemed like it was a training study for people with aphasia to, you know, actually get some extra practice in naming. But I'm wondering, say if you're working with older adults and maybe it takes them a little bit longer to process and formulate their answers, if the speaking is actually going to end up being a better method than just answering the questions like you have it. So that was one area I wasn't sure if like what you get with the younger adults might actually translate to, say, an older adult population.
Yeah, well, I mean, you're absolutely right that it's not just about, well, how fast you can answer it, it relates to the cognitive burden. So if I ask you a question, I mean, you can think of yes, no questions that are very theoretical that are hard to answer, right? It might require a lot of cognitive burden to answer that question. So just because something's got a small number of responses doesn't necessarily mean the question is cognitively easy to answer. And not all questions, obviously, that researchers want to want people to answer are going to be cognitively easy to do. And of course, when it's open-ended, like in the audio, that is one of the things we're trying to figure out right now. So when we tell people, again, we're starting with physical activity because that's where we have the most experience to some extent, and the biggest problem at the moment in terms of things we want to be able to label better. When you ask them in an open-ended way, say what your posture and activity is, then they have to decide what to do. And in the little pilot with the audio input, some of the people give much longer responses and some of the people give shorter responses. And one of the things that the conclusion that we have drawn so far is we really, really want this to be real time and interactive, in part so that the system can train them to answer in the least burdensome way. And again, we kind of run into the problem that while we can create like a prototype of that might work in the lab, it's hard even just to deploy small numbers of those in the field and have it work reliably because of the battery life, phone, blah, blah, blah sort of issues.
Yeah,
so
I was almost thinking like some pre-training of people, like get them used to the type of responses that you want, but then you don't want people to just be stuck in those responses, right?
Yeah, it's a good question, right? And I think the long-term vision again is that the system behind the scenes would have a rich enough model of what's going on that it would drive to some extent the asking of questions, and it isn't necessarily that it's just this one way of asking. The way of asking may change dynamically for a variety of reasons. One is to encourage engagement, and the other is to maybe help tease apart different bits of what the answers really mean. So long term, I think we would see less and less of what we have today, which is that the questions are very rigid, set up from the start, and they never change. And initially anyway, I think what you're saying is what we do when we bring the people in is we say, this is what we want you to do. We want you to do posture and activity. And here's an example, here's examples. But even that, it evolves over time. So people, they start doing one thing one way, and if they're not getting feedback, it just changes, right? So by the end of a couple of weeks, they're doing something different than what they were doing at the beginning. And that's why we think we need the real time.
Thank you. Great work.
Very, yeah. Larry, you had a question?
Yes. Hi. Yeah, my question is in regard to incentives for them to keep answering the questions long term, and not, turn off the app or disable notifications. So I was wondering in your studies if the participants indicated anything like, I enjoyed the interaction, or I wish I could see my results, so any insights that we might be able to give them feedback that would incentivize them to keep answering these questions long term.
Yeah, I think that's a great question. And I want to incorporate incentives, because I want the questions to be more like text messages, right? The reason people answer most text messages that people get aren't that great, but every once in a while they get one that they love, right? And that's what keeps you coming back. It's that rush, right? And when we do EMA studies, I've had very explicit conversations with collaborators at times and said, let's put something in here that has nothing to do, let's try to be a little edgy. Let's get something in here that's surprising. And I get a lot of pushback about that for two reasons. One is because people say, well, we're prompting them, it's another interruption. We don't want to add an interruption and then risk the idea that they get annoyed with us because this has nothing to do with the study. So that's one bit of pushback. And the other bit of pushback is, well, this might, we're doing a measurement study and this might change how people are feeling or acting or something like that. So it's risky. Why don't we not do that? Like, let's just not do that. We'll just pay people to do this, and you can pay people to do it if it's a short-term study, but long-term, again, it doesn't really work that well to pay people. So I am 100% on board with the idea that this should include incentives that are as clever as possible to get people to engage with this. That really requires a shift in thinking, I think, at least with many researchers, because it isn't the way that most people do EMA. So we definitely have had simple thank you messages, and I've pushed to try to make, like in the time study, the year-long one, they weren't getting anything for answering the stuff on the watch, but they did, after they did every question, there was always something, always a follow-up, and those were all unique. So they were never the same. Like it was some little thank you message. And there were, like corny messages and stuff like that. Nothing super exciting, but at least it was a tiny little bit of novelty. And I think we need to figure out a way to get that into these, even in the measurement studies. Now in intervention in the long run, the hope is that if my computing device, if it can do something I like better because it can recognize my habits, then I have an incentive to give it information. Right now, most people aren't really there yet, right? Again, because of the limitations. And so certainly what I do is mostly been measurement studies. So there's nothing in it for them other than helping out science and a little bit of compensation. That's basically what's in it for them. They're a little bit interested in seeing like a summary of their data, but that doesn't last very long. And it's kind of, like there's only so many ways we can show them stuff that's not super interesting to them. So in the long run, I think it has to be that these long-term health interventions, people have to feel like they're getting value out of it. And they have to feel like when I give it information, it's going to work better, which is a whole nother set of challenges for activity recognition people. How do you do that and make that work? Because the algorithms right now, most of them are just kind of like, give me more data, I'm going to work better, right? But then if I give it more data, even if it works better, if on the example that I wanted it to fix, it doesn't fix, it's going to be total frustration for an end user. So that's another area that I'm interested in, and we've tried to pursue a little bit, but unless you can really build robust real-time systems, it's hard to do the studies that we want to do. So we're hoping that the watches get more reliable soon.
Great, thank you.
Time for one more. One question I had was, so you have done 2-second glance. And so I immediately thought, why not just buzz them and have them talk? Now you've done that. What about gesture? And I recognize that when they're carrying groceries, they won't be able to gesture, but they could have an option to either speak, gesture, or look at the watch. Mm-hmm. Is your feeling that the gesture response would work and reduce burden? Would it be a good option?
You mean if you had cameras or something else, or Wi-Fi sensing or something in the house, or like, how would you recognize when you say, or from the wearable, just from gesture from the wearable? Yeah. Oh, I see. Yeah. I think in the perfect world, they would have options about the way they can respond, and the system would know enough about what they were doing to even prompt them maybe in the way that's most convenient for them in a given moment, right? So if gesturing makes the most sense, then they would be able to do it that way. I think the place where gesturing is useful is because of this thing, like they're more reluctant than I would have thought about this, about speaking when other people are around. And so they're saying they would prefer to just not have that. They're worried that people are going to think they're weird because they're just saying some word out of nowhere. And so they would prefer to look at the watch and then answer the question. So that would be a case where a gesture, certainly a gesture like not right now, ask me later, right, could be very helpful. But they have to learn those gestures. So it's making the system a little bit harder to use, right? But I can see the value in it. We haven't done it.
Right. Okay. All right. Well, thank you again for your time, your insights, your ideas, and that was really valuable for us. So we appreciate it.
Oh, yeah, my pleasure. And if anybody wants to try this technique in the future and has questions or anything like that, I'm always looking for looking for collaborators, and we're excited when people try it. There's certain domains where it makes, we think, a ton of sense, other domains where it's harder. But thank you for having me.
Yes, thank you.
Thank you.
Have a good day, everybody.
Bye-bye.
Bye.